Good morning. I'm Alan Collins, a research zoologist with NOAA's National Systematics Lab and a curator in the Department of Invertebrate Zoology. So my curiosity about life on this planet is often piqued by phylogeny, and this probably goes back to my time as a graduate student when I was very interested in the dawn of animal life, and phylogeny told me that I needed to know more about these organisms, those that diverged during what I like to call the period of beauty before brains, the sponges, the comb jellies, placozoans, and cnidarians, which we'll turn to now. Cnidaria is an animal phylum of two main groups. There's the corals and kin and the jellyfish and kin, about 10,000 species. And we'll focus on two of the jellyfish groups, the box jellies and the stalked jellies. Box jellies are remarkable creatures. There's only about 40 known species, but they kind of have an abundance of charm. For instance, they have rather complicated sensory structures. These come in fours, and each one is endowed with a balance organ and numerous eyes, some of which are capable of forming images. That is, they can see. But box jellies are particularly notorious for the fact that some species can cause very serious stings. There's one species in northern Australia which can kill an adult human in 5 minutes if the venom load is sufficient. And box jellies, and indeed all of the cnidarians, deliver their venom by microscopic nematocysts. These are capsules under incredible pressures with a coiled up tubule inside that everts, and out comes a cocktail of proteinaceous venom. Now, we're interested in the evolution of venom, nematocysts, eye structure, all of these things, and we build family trees in order to inform our understanding of how these features have evolved. At the same time, we've created a database of genetic barcodes for box jellies, and I draw your attention to this part of the tree here, which groups species based on their genetic similarity. This part of the tree contains species that vary greatly in size, but which all cause Irukandji syndrome. This is a syndrome that involves severe lower back pain, cramping of the arms and legs, nausea, anxiety, and what's described as a feeling of impending doom. And so when we stumbled upon this new sequence of an unidentified box jellyfish from Malaysia, we were very able to quickly identify it as a likely member of this family, and as such a likely health concern. Because they have such charisma, we've been able to capitalize on box jellyfish to conduct biodiversity outreach. In this example, we engaged the public in science by conducting a public species naming contest, which highlighted how we document biodiversity, and also brought the world Tamoya ohboya. So, but what about less charismatic, somewhat less obviously relevant groups of species? The stalked jellies make a great contrast to the box jellies. It's also a small group, about 50 known species, mostly from colder waters. But they don't have stings that can penetrate human skin. They can't see, heck, they can't even swim. But we're interested in them anyway, and so we've been sampling them from around the world. I'll tell you one quick story. Among all the different organisms we've sampled, one was a microscopic hydrozoan polyp, but when we sequenced it, we found out that in fact it was a stalked jelly. So it was a completely different class. And so using a genetic barcoding type approach, we were able to discover an unknown life stage in a stalked jelly. And this life stage lives only on one species of clam. Now, this highlights how little we know about the basic, important aspects of the lives of most of the species on this planet, many of which are threatened. And indeed, there's anecdotal evidence that some species of Staurozoa have been in peril for more than 100 years. Here's Mayer in 1910 stating that contamination of the seawater in this region has destroyed the Staurozoa which once abounded there and which are now exceedingly rare along the entire New England coast, and still so. And of course, we're going to be really excited when we can encounter new and poorly known species of stalked jellies and incorporate them into our global studies. But it's unlikely that most of these, just like most organisms on this planet, small and rare, that they are going to cure cancer, cause us harm, or have direct relevance to humanity. So we're often asked to make our science relevant, but I think we need to spend some time also to tell the natural history stories of some of the less relevant species on this planet. Each one of the millions on this planet are connected to us through the invisible lines of phylogeny, and each one has persisted as they're the living representatives of lineages that have persisted for millions and millions of years through changing environments at any given point in time, interacting with other lineages themselves, all evolving. Species have an inherent value simply because they're such fascinating entities. And I think that as we sit in the sixth great mass extinction, the more we understand that, the greater the value we're going to put on them, thereby creating a stronger ethical imperative to not simply watch them disappear. Thank you. The question is, venoms are often useful, and are there any known uses for box jelly venom being developed? There are definitely people that are working on that, so it's true that any given species can definitely have human impact and human relevance, but there are millions of them, and what is the percentage? And we can't stop telling the stories about the other things because we need to inspire natural historians.